Welcome back, everybody. We've got Gareth here at the helm. I'm Tony, and we're going over the Murray-Darling Basin. In this particular part, we'll be going over the New South Wales data, and we'll be getting Gareth to describe and illuminate what is actually going on here.
Guys,
G'day, Gareth.
thank you very much, Tony. Thanks, guys, for having me back. Okay, so the last slide that we talked about the different issues, and over the last couple of slides, we've gone over the different issues impacting the Murray-Darling River.
Yeah, the preceding events and the effects of what the crisis is causing.
Exactly.
So
Right.
what we're looking at is we went over the symptoms.
Correct, and these are all symptoms that are, at the root of it, caused by increased nutrient and increased waste input into the river system. Okay, so
Which we discussed is not likely to decline because industry does need to be where it is.
and population is where it is, and we need access to water, and generally speaking, populations gathered around sources of water, rightly so, smartly so. But we talked about a compounding effect, and we're talking about the compounding effect of the symptoms that we're seeing downstream, as well as the causes compounding downstream as things happen, like floods and things like that. And this is an excellent representation of those compounding issues. Okay, particularly in regards to both fish kills and algae blooms. And it's important to note that fish kills are fish kills. Okay, it kills everything. Hard to miss, right? Algae blooms, the right hand side graph is only representing blue green algae. Okay,
Yep.
which is a very, very good indicator of very high nutrient and a very bad environment and very bad water quality. The other algae species blooming, like we've talked about, if we were to record all those, that I reckon that right hand side of the map would just be green and red. So
Yeah.
okay, so it's important to note that even with the density of dots in the right hand side graph, that is only blue green algae, just because blue green algae has toxins in it and it's a health risk and we need to monitor it.
Yeah. So that
Okay.
doesn't cover all other cyano bacteria.
Cyanobacteria, any algae, any hair algae, any single cellular algae, anything like that.
All
And we'll
right.
go
So
into a different couple of types in a couple of later
yeah,
slides.
sure. So these were pulled from the Parliament of New South Wales, from the Parliamentary Research Service.
Yes,
Are you able?
they do an
Yeah.
what's called a publication called the Issues Backgrounder, and this was from number 2 in July 2019, around the time of when the many fish kills and things like that.
Yeah.
Okay, so this is
So
up.
they're
This
they're
is
collating the data
2019.
and they're aware of something actually happening.
Yeah, well, as we can see from the graphs and the pictures, so we'll start on the fish kills on the left hand side. All right,
Yep.
so you can see that we have 4 different time periods on the right-hand side, and the keys under those time periods enable you to see the size of the fish kill, indicated by the size of the dot that is present. The four periods of time are before 1960, 1960 to 2008, so 48 years, 2009 to 2017, so 8 years, and 2018 to 2019. So you can see that the brackets of time that we have decrease in time exponentially as we get further on in history and further down the line of the history of the Murray-Darling River. Okay.
So it shows that they've been monitoring the situation, but they've also been seeing an increase in fish kills over the last 60 odd years.
Yeah, indeed. Yes, 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 yes. So before 1960, you can see there are a few dots there that would indicate the recorded fish kills before 1960. There aren't very many about. Okay.
No, but they are in those hotspots.
They are. That could be due to a couple of things. It could be due to just population, that there wasn't as wide a population across as many areas of the Murray-Darling River. It's more than likely to do with the actual collection and collating of the data, as well as things like monitoring in remote areas that wouldn't have been a thing back then that is now.
Yeah,
So
well, you're only going to get data from places you go to collect the data.
yes, but having said all of this, the remaining data supports the fact that there's still not very many fish kills before 1960. Okay, so we
Yeah,
can see that from this graph. There's a couple in the middle of New South Wales here. That's about it. That's all I can really see. Okay,
yeah.
in the middle, in one of the tributaries of the Murray-Darling River system. So from 1960 to 2008, which is a period of 48 years, the yellow dots you can see at the start of the Murray-Darling River, and then as they increase down the Murray, where it meets the Darling and then comes into the Murray-Darling River, that we have a compounding effect as it starts near the Queensland border,
Yep.
but then goes down and starts to increase in both size and frequency as it goes along, where it meets the Darling River and turns into the Murray-Darling, and then continues along, towards the
So
border.
it follows at the top, down along the
Mhm.
left, and then heading back down along the bottom of Victoria towards the right. You see the larger yellow dots
Yes.
indicating larger fish kills.
And you can also see the tributaries that flow in or out of of the Murray-Darling River, that there are also fish kills there as well. So whether or not it's bad water quality that's further compounding and flowing into the Murray-Darling, or whether that tributary is flowing out of the Murray-Darling and it's already got all those compounded issues, either way, it's a problem. Okay.
Yeah, and it's important to note that the largest dot there is in a magnitude of hundreds of thousands in a
Correct.
fish kill.
And there's one of those there, and the next size dot down there is quite a few. The next two size dot downs there is quite a few, from thousands to tens of thousands, which aren't numbers to balk at either. They're significant.
Yeah.
If
Well,
you
how
said
much
to
would
an
100,000 fish weigh?
okay, so 100,000 fish. If you put each fish at a kilo, that's 100 tons. If they're half a kilo each, or 500 grams, which would be considered plate size,
Mm-hmm.
just for people's reference at home, 4 to 500 gram fish is considered a plate size. That would be 50 tons if it's 100,000 fish. Now, 50 tons is 50,000 liters. So if you are playing at home and you have a 50,000 litre pond or a 40,000 litre pond or something, go outside, look, pool, sorry, pond. I've got aquaculture on the brain, sorry. Pool, swimming
Well,
pool.
good. We need you there.
Yeah, right. It's kind of important that I stay here. But you go outside, you got a 25,000 litre pool or a 50,000 litre pool, and you imagine taking all the water out of that and filling that up with dead fish, and that's what 100,000 fish at 500 grams looks like.
Yeah,
Okay.
and we're talking in the magnitudes of today's issue in the millions of fish.
That's an estimate too. You got to imagine they didn't really go and count every single fish. There would have been fish that would have died and decayed in that time. There would have been fish that got swept down river that wouldn't have been able to be counted.
Hmm.
Um, the compounding issue that I'm getting at is whether it's flowing into or out of the Murray-Darling. It's the Murray-Darling basin and its tributaries which flow in and out of the Murray-Darling, which contribute to or further compound the issue into or out of those tributaries. So we're not just talking about the Murray-Darling river system here. We're talking about every river system that's connected to it, because every river system that goes into it further compounds the waste issue, and every river system that comes out of it has obviously got all the issues of all the Murray-Darling river system and its tributaries beforehand flowing into it.
Yes.
So it's not like we can just focus on the Murray-Darling river system here. It's all the tributaries that flow into and out of it are also important, because that's where urbanization is coming from as well. The water's got to go somewhere, and all roads lead to the ocean,
Yes.
essentially, for lack of a better description. Um, So moving onwards into the next time bracket, so we've gone from 48 years in the period of 1960 to 2008 to 80 years in the period of 2009 to 2017. Now, if we look at the red dots, we will see that there are quite a few red dots up near the Queensland border that then flow into the Murray River. There is a very big red dot slightly down just south of the New South Wales border, which then continues on, and you can see that there are a number of red dots increasing in number and frequency, moving along that same path as the yellow dots did. Now, the most important thing to realize here is that I would say that in frequency and size, we're probably looking at maybe 30% less data points on that map, Tony.
Yeah.
But it's in a period of 8 years, not 48.
Yeah.
Okay. So it's about 20% of the time period, and we've only got 30% less than a 48-year period beforehand in 8 years. That's pretty significant, I would say. It shows that not only the compounding issue is there, but that also the fish kills are increasing in number and size and frequency over a period of years. Now, in the period of 2018 to 2019, we can see that there's very few dots. There's a few up near the Queensland New South Wales border. There's a couple of big ones at Menindee, which is where all the publicity, or everything came from. This all came to light, things like that. But you can see another couple of grey dots down further in the river system. Now, again, much less data points, but this is literally in the space of 1 year now.
Yeah, you're talking about 12 months.
Now, you times that by 8, the amount of dots there on there by 8, and you'd have something that's representative of the 2009 to 2017 time period. You times it by 48, and I guarantee that entire map would nearly be grey.
Yeah,
if you worked on the same frequency, I'm saying here.
Yeah,
right?
Exactly.
So the same frequency and number.
It's becoming compounded. Yeah. It's compounding.
It's the compounding option, and it's increasing in intensity exponentially as things move further down, because it'd only be getting better if we stopped the waste and the nutrient upstream and at all points along the river going into the river, and that's not possible.
Yes.
We can't do this. So yes, it's plain to see from that data that is what's happening. Okay, whether it's flowing into or out of all of the rivers and tributaries of the Murray-Darling River system, including the Murray-Darling River itself, is suffering from these issues. Now, you'll notice that there's no data points north or west of the New South Wales border.
Yeah, it dips a little bit into the no, actually it does not. It follows the Victorian border as well. So this is only the data from New South Wales.
Correct. We're not talking about data from Queensland, and we're not talking about data from Victoria either.
Yeah, it affects all of that plus South Australia.
Now the majority of the Murray-Darling River flows in and around through New South Wales, as we can see. There's a big area there, but as water continues down through the Murray-Darling River, can you imagine how bad it is from the data in Victoria that we haven't looked at? We're just looking.
Well,
at
yeah, we're seeing flow on from Queensland down into New South Wales, and now we're going to have all of New South Wales flow into Victoria.
Now, look, this isn't a dig at Victoria. Okay, I love Victoria almost as much as I love not going anywhere. Okay, but it looks like, unfortunately, Victoria might be the end of the pipeline in regards to the sewage treatment works in that analogy, because they're getting the worst of everything.
They're getting the raw end of the stick.
Yeah. Ooh. At that point, I don't even think there is a stick. I think it's just a bucket. But yeah.
All right. So if you could explain to the viewers here how the data on the left correlates to the data on the right.
So the data on the right here shows the intensity of blue-green algae blooms in the Murray-Darling River system. And that is algae alerts as of the 1st of July 2019. So it was last updated algae alerts between the 7th of May 2019 and the 20th of June 2019,
That's a month
and a bit.
and a bit.
Yeah, give or take, you know. So
What, roughly 6 weeks?
roughly. So
And this is
so now
right.
what we need to realize here is that the fish kills are the symptom of the absolute last thing that will happen before catastrophic failure. Okay.
Yeah.
So that is, we're just looking at fish kills. We're looking at when the river goes, I no longer have anything left in the tank. It's all up to you. I'm giving up. And that's when you get a fish kill when a hypoxic event occurs and everything's just going not in the favor of things that need to live in the water.
Mm-hmm.
Now, algae will bloom in different intensities, as we will see by the red, amber, and green dots that indicate their intensity along the river system of the Murray-Darling and its tributaries, as well as this is only over the portion of 6 weeks, not over since before 1960, like we see on the left-hand side. Okay, so
So
in the
this
space
data
of
is more correlative to the 2018, 2019 on the left. This is the 2019 map of a 6 week period in New South Wales for
of a
algae
6 week
alerts.
period in New South Wales between the 7th of May and the 20th of June. Now, if you were to map every single algae event, even just blue-green algae in the same time period, I wouldn't like to imagine what that looks like. Now, the blue-green algae is a symptom of the cause being increased nutrient input into the river system as well as increased sediment. Blue-green algae, as we've discussed, is a cyanobacteria. It can not only feed on waste, but it can also store that waste, and it can also photosynthesize just like an algae. It's incredibly it's incredibly it works on it takes advantage of a very bad environment in water quality. Okay,
So
it's
it's
very
advantageous
it's
and
advent yeah it's not
it
advantageous. Well, bad water quality environments are advantageous to it when that is not suitable for a lot of other species of life.
mm,
Yes. So you can see the varying intensities, either red, amber, or green. Now, as you can see, within the year, the river systems that flow into and out of the Murray and the Murray-Darling and the Darling increase in intensity, both intensity and number, just like we've been seeing over the years with fish kills, and also on a compounding basis on the left-hand side. It gets worse as it goes downstream. So does the blue-green algae. Now, again, it's very important to stress this data is just from 6 weeks in 1 year.
mm.
So you can clearly see the compounding effect of data that's taken in a 6 week period. What would be the compounding effect if we watched it on a yearly basis as the data was taken, as that data filled up over a period of before 1960 to 2019? I think we'd be shocked. So we can see again that the compounding effect of increased nutrients, sediment, and everything further produces an environment that is advantageous for blue-green algae to bloom and proliferate. And you can clearly see how it compounds as it goes downstream and how it, progressively gets worse. Now, again, only a 6 week period, so only a very small snapshot.
Exactly.
Very
So,
small.
and once again, the algae itself is also a symptom, not the cause.
Exactly. It's the symptom. It's only going to grow if the conditions are right for it, and the conditions are right for it being an increased level of nitrate and phosphate and an increased level of sediment in the base of the river system or the water body that holds a lot of nutrient in what is called a nutrient sink. And it is also then constantly re-releasing nitrate and phosphate as well. So as the blue-green algae is taking up all the nitrate and phosphate in the water, nitrate and phosphate is coming out of this sludge in the bottom as well, and just further fueling the problem. So you've got to treat all the causes, not just one.